So today I will start to design the truss bolted connections. Just to give you a hint, just a reminder what we covered until this moment. We have a main system, looks like truss, and we can draw a layout. We can calculate dead load, live load, wind load, and snow load. We can use RISA 2D to analyze this truss. And finally, I can tell you what is the internal force in each member: axial force, tension, or compression. If the member is tension, I can design it. We learned last week how to design tension members. And last meeting, we learned how to design compression member. That's right. So right now, we need to figure out how can we design this connection. We have 3 or 4 or 5 members connected together at a joint. How this joint looks like, and how many bolts I need. Guys, remember, we have exam next week, Thursday. Next week, I think February 18. Yes. All of this story will be included in the exam: layout, loading, RISA analysis, design of tension member, design of compression member, and design of connection. What I'm covering today. Any question? Any question? Okay. So guys, we have 3 different types of connection, or 3 different ways to make connection. We can do connection by welding. Can you see this member connected to this gusset plate by welding? I cannot see any holes. I cannot see any bolts, just welding. Or by using bolts, or by using rivets. But rivets, it's a very old fashioned, very old bridges built in 1950s, 1960s. All of these bridges were built by using rivets. We will no longer using this technique in connections. We are using welding. We are using bolts. Okay. Just for your information, if you have bolted connection, we have different types of mode of failure. The first mode of failure, failure of the bolt, failure of the fastener itself. Shear off. Can you see this? Failure, shear off. We have tension in this side, and we have tension in this side. So we have shear on the bolt. Guys, here is a bolt. Looks like this. The upper part is here, like this. The lower part is here, like this. That makes sense? So if you have tension in this part and the tension in this part, so what do you expect for the bolt? We expect shear, because this force and this force are perpendicular to the shank of the bolt. So we have shear will cause shear off or failure of the fastener. This is the first mode of failure. The second mode of failure, the bolt is good and can support the applied force, but we have failure in the material which are, or the material which is connected. So failure of the parts being connected in the member itself, in the gusset plate, like net tension. Can you see here? This failure in the material itself for the of the member or the part being connected, or something called shear out. The bolt is here, will try to get this part of the material out, or bearing failure. Can you see the bearing failure? Something like this or like this. We have a bearing between the bolt and the surrounded material, so we can expect bearing failure. Anyway, this slide can tell you what are the different types of mode of failure. The first mode of failure, which is very rare to happen, shear off or failure in the shank of the bolt. The second one, which is common, failure in the parts being connected, failure in the member itself, failure in the gusset plate, all of this stuff. For your information, I would like to explain it here in more details. Guys, sometimes we have this plate and this plate connected to this plate. Does that make sense? Or this plate is connected to this plate. Only two plates connected together, or three plates connected together. Sometimes we have this connection, two plates from this side, and we have two plates from the other side, probably for some reason. If you put a bolt here and the bolt here and the bolt here, what do you think? If the force here is P, I believe the force in this plate will be P divided 2. This plate will be P divided 2. If you have a force here P, I believe the force in this part will be P. Does that make sense? If we have here P divided 2, we will have here P divided 2 and P divided 2. So guys, what do you think? How many shear plane in this case? Only one. I'm sorry, what you mean? I mean, if you would like to draw the free body diagram for this bolt, the upper part, which is following this part of the member, will be under the effect of P. The lower part, which is this one, is following the part of this member under the effect of P. So this plane of the shear in the bolt under the effect of a force equal P. What is the case here? I believe this bolt can be divided to three parts. This part, and this part. Let's see. The upper part, the lower part, and the middle part. What do you think? The upper part will move in which direction? Following this member. The lower part following this member. What about the middle part following this member? That makes sense? Okay. What is the force at this cross section? Do you think this force is P or P divided 2? I believe the force in this part is P divided 2. I believe the force in this part P divided 2. So the force transmitted between this part and this part is P divided 2. And the force transmitted between this part and this part is P divided 2. So which one will be more critical? I'm talking about the same bolt, same material, same diameter, everything's the same. Which one will be more critical? This case or this case? Which one will be more stronger? This one or this one? Any answer? What do you think? So Oliver, you said the two blade cases are stronger or more critical? Stronger. Okay, if I have question. If the bolt can support 10 kip, this bolt can support 10 kip, and this value of P equal 12. Which one will be fail? Which one will fail first? If the bolt can support only 10 kip, so P equal 12. It's given 12. And the bolt can support 10 only. I believe this one will fail. This one will be safe. What will happen if the bolt can support 12 kip, not 10? This one will be safe, but critical. Very critical. This one is still safe. More safe. Why? Because the force on the bolt itself is P divided 2, not P. But in this case, the force on the part of the bolt is P. So this case will be more critical than this case. This case will be stronger, will be more safe. Okay? So guys, just to keep in your mind, sometimes we have something called single shear. Sometimes can be called double shear, based on how many parts you are connecting with and how many planes of shear the bolt will be sheared off. Okay? Just to keep it in your mind, we have something called single shear, we have something called double shear. Guys, we remembered and we learned we learned. Sometimes the member can be single angle. Sometimes the member can be double angle. That's right. If you have single angle, the gusset plate will be connected to this leg, for example, and we have bolt. If you have double angle member, the gusset plate will be in between the two angles, and we have bolt. What is the difference between this case and this case? We have a huge difference. In this case, we have single shear bolt. In this case, we have double shear bolt. This one and this one. Does that make sense? That makes sense? So please be careful. Sometimes your connection or your bolt can be considered single shear or sometimes double shear. Is it important to understand this point? Yes, it's very important. We need to design. I need to figure out how many bolts I need. It's very simple, very, very simple. The design shear strength for one bolt equal 0.75, the value of phi, time n, small n, time F NV, time area B. If you multiply 0.75 time N time F time A, you can get the design shear strength of one bolt. Can you explain it in more details? Yes, I can. Area B is the cross-sectional area of the bolt. Guys, your bolt looks like this one or looks like this one. The bolt has a diameter. You remember the name? DB. The area of the bolt equal by divide 4 times this diameter square, because the area of the cross-section area of the bolt is a circle. If you know the diameter, I can tell you the area of the cross-section of this bolt. So area B, the cross-sectional area of the bolt. Does that make sense? In how many shear planes do you have? If the bolt is single shear, N will be 1. If the bolt is double shear, N will be 2. So it's very important. It's very important before designing the connection to figure out how many bolts do you need. I'm sorry, to figure out how many shear planes do you have. Is it single shear bolt or double shear bolt? Because previously you decided this member will be single angle or double angle. That makes sense? So you can decide this connection will be single shear or double shear. What about FNV? FNV is the nominal shear strength. If you open this table, I can tell you what is the value of FNV, the nominal shear strength in KSI. 27, 54, 68, 68, 84. Which value I'm gonna use? You have to learn. We have two types of bolts. This bolt, we have two types. The first one called ordinary bolt, which called A307 bolts, or high strength bolt. If the bolts are high strength, we have two groups, group A and group B. And also, we have for each group two cases or two scenarios. Can you see the threaded part of the bolt? Sometimes the whole chunk of the bolt is threaded. Sometimes part of the bolt is threaded and the other part is not. We need to understand, we need to determine the shear plane, the shearing plane is through this threaded part or not. So if you go back to this table, the first type of bolt, which is ordinary bolt, has a value 27. That's it. The second type of bolts, high strength bolt, we have group A and we have group B. Group A can be divided to when threads are not excluded from the shear plane, or when threads are excluded from the shear plane. So you need to decide, do you have threaded for the whole chunk of the bolt, or you have threaded only for a simple or a very small part, and then the remaining one will be excluded from the shear plane. Based on this assumption, I can decide which value of FNV. So guys, area bolt, I have to assume a diameter to be used. Then I can figure out the area of the cross section. FNV, I can use this table to figure out the value of FNV based on your assumption, what type of bolts you are using. Before starting to design, you have to decide which type of bolts I'm gonna use. Most of the time, we are using this type of bolts, the ordinary bolts. Very cheap, very simple, common, and used in design of trusses. Okay, I will multiply this value by this value, by this value, by this value. The final product will be called design shear strength of one bolt. If you would like to figure out how many bolts I need, you need to divide the B ultimate by this value, the design strength of one bolt. So phi Rn is the design shear strength of one bolt. P ultimate, the factor, the axial force, you did it from structure analysis. You get it from RISA. 1.2 dead load plus 1.6 life load, or whatever the combination. P ultimate, the factor, the axial force, tension or compression, whatever. Tension or compression from structure analysis. Divide this value by phi Rn, I can determine how many bolts I need. Is it easy? Before starting the first example, we have few requirements. If you would like to arrange your bolts, we have minimum spacing between center line of this bolt and center line of the next bolt. This distance must be greater than or equal 3 diameter of the bolt. So AISC requires that center to center spacing of fasteners be no less than 3 diameter of the bolt. The minimum distance between the center of the last bolt and the edge of the member, which called edge distance, must be following this table. Based on the diameter of the bolt, I can tell you what is the minimum distance. That makes sense? So this slide can showing you the how you can arrange the bolts. We have minimum spacing center line to center line. We have minimum edge distance between the edge of the member and the center line of the last bolt. This minimum distance is following this table based on the diameter of the bolt. Okay, let's do this example. We have connection, which is given, and the problem asking to check the bolt spacing, edge distance, and the safety of the connection. Okay, let's start with the spacing. What is the given spacing between this bolt and the next bolt, center line to center line? S is given 2.5 inch. Do you think this spacing is okay or not okay? Edge distance is given how much? What is the edge distance here? The center line of the last bolt and the edge of the member is given 1.25. Is it okay or not okay? Any answer? What do you think? Based on the standard, the minimum spacing between center line to center line bolts must be 3D bolt. Okay. What is the diameter of the bolt? Actually, we are using 3/4 inch diameter bolts. So 3 times 3/4. What is the distance? 2.25 inch. Do you think the given distance is smaller than the minimum one? No. So this one is greater than 3 dB. We are good. No problem. What about the edge distance? LE minimum. We need to use this table. Okay. To use this table, we are going to use the 3/4 diameter bolt. 3/4 diameter bolt. The minimum edge distance is 1 inch. So the minimum edge distance is 1 inch. Do you think the edge distance which is given 1.25 is smaller than the minimum? No, it's greater than LE minimum. We are okay. Part number 3. We need to check the safety of this connection. Okay. P ultimate equal 1.2 dead load plus 1.6 live load. We have dead load equal 15. We have live load equal 45. Okay, the final value of P ultimate 1.2 times 15 plus 1.6 times 45. This value will be 90 kips. What is the design strength of one bolt? One bolt equal 0.75 N FVN area bolt. Let's do it. 0.75. How many number of shear plane? I believe it will be one single shear. Nothing else is given, so I will assume it's single shear. FVN, the type of bolts is not given. I'm gonna assume it's ordinary bolt, the first type. So the ordinary bolt, the value of FNV or VN, 27. What is the area of bolt? Pi divide 4 times this diameter square, 3/4 square. What is the value? .95 kips. Can you tell me how many bolts I need to support this force? The number of required bolts equal P ultimate divide phi Rn. Divide this number 90, divide this number 8.95. So what is the value? We need 10 bolts. We need 10 bolts. How many bolts do you have in this connection? How many bolts are given? 1, 2, 3, 4. I'm sorry. We need 8. We need 10. So that means this connection is unsafe. That makes sense? That makes sense? The problem asks to check the bolt spacing, the edge distance, and the safety of the connection. Do you think this connection is safe or unsafe? I get the design strength of one bolt. What is the P ultimate in the member? It's under tension anyway. So I calculated how many bolts I need. I found I need 10. However, the given bolts are 4. That means this connection is unsafe. One more example. But before going to example, do you have any question?
I have a question.
Yeah.
So we checked the spacing and it's good, the edge distance and it's good, but the only thing that's not good is the amount of bolts we have because the connection is not safe.
Yes.
So this is not safe. But what if we got a question like this, let's say on the test, and we started by the very first thing, let's say the spacing, it wasn't okay. Do you want us to stop and just say that it's not safe, or do you want us to?
No, you have to keep going. You have to give me an answer. What about the spacing? What about the edge distance? What about the safety? You need to answer all of these questions.
So it's possible to have a safe connection and a safe edge distance, but not a safe spacing?
Yes, sometimes.
Okay.
This problem, guys, this problem looks like a real problem. Looks like you are engineer and going to Walmart, for example, and trying to figure out what is the problem in the connection in the roof of this building. So you are trying to figure out what is the issue, what is the problem. I need to check the safety. So you need to check everything about the spacing between the bolts, about the edge distance, about how many bolts. You need to give me a detailed report as engineer. You know what I mean? Okay. The second example, determine the design strength of the connection. We have a connection with 2 bolts only. Please, can you give me what is the design strength of this connection? This connection can support how much force? We need to, I didn't ask about the member. I'm not asking about the member, how much this member can support. I'm asking this connection with 2 bolts with 3/4 diameter, 3/4 inch diameter. How much this connection can support. The problem is giving you 2 scenarios. If you are using this type of bolts, so let's start with this one, type A 307 volts, which is ordinary bolt. The first step, what is the design strength of one bolt? Pay Rn, very simple, 0.75, small n, F Vn or Nv, whatever, area bolt. 0.75. How many shear planes? If nothing is given, I'm gonna assume it's one single shear. FVN, I will go back to this table based on the standard. The first type of bolts, your value of FNV, 27. Area of bolt by divide 4, the diameter is 3/4 square. I can figure out the strength will be 8.95 kip. So the design strength of this connection equal 8.95 times 2. Do you know why? Time 2. 8.95 times 2, 17.9 kip. Guys, keep in your mind, this value is the design strength of one bolt, but this value is the design strength of the whole connection, because we have 2 bolts in the connection. I multiplied the design strength of one bolt by 2 to get the design strength of the connection. That means I am looking that P ultimate to be smaller than or equal 17.9 kip to make this connection safe. That makes sense? I'm talking about the connection because we talked before about the member many times. Okay, let's do another example. Actually, I didn't finish this one. I didn't finish it. We have another situation. If you are using second case, if you are using group A bolts and threads in the plane of shear, in the plane of shear. Okay, we have to start. What is the design strength of one bolt? 0.75 N F in V area B. 0.75, we have only one single shear. F N V group A. So probably I'm gonna use this one or this one because you are talking about group A. But the first one, when threads are not excluded from shear plane, I believe you are here. Because the second one, the threads are excluded. But we are here, threads in the shear plane, so it's not excluded. So your value will be 54. And the area bolt by divide 4 times 3/4 square. I can figure out this value. It will be 17.9 kip. So the design strength of the connection equal design strength of one bolt times 2, because we have 2 bolts. So it will be 35.78. Wow. So P ultimate must be smaller than or equal 35.78. Guys, just I didn't change anything. I didn't change anything in the connection. I only changed the type of bolts. This connection for ordinary bolt can support only 17.9. When I change the type, I didn't change even the diameter. I didn't change the diameter of the bolt. The only change is the type of bolts. I can get a higher capacity, 35.78 kip. So I'm trying to give you different solutions. If you have issue with a connection, it's not safe, you need to do something, okay, you can keep everything the same, the number of bolts the same, the diameter is the same. The only change I did, I changed the type of bolts.
Dr. Ayman?
Yes.
When you said when threads are not excluded, what do you mean by that? Like if they're, what do you mean by that?
I mean, threads are not excluded. that means it's included. I mean,
Okay, I see what you mean. That means if it's partially threaded, if the bolt is part. Okay, I see what you mean.
no, it's not partial. I don't care. My curious is, do you have threaded part here at the interface or at the contact between the two plates?
Yes.
If you have, okay, you are here. You
Yes.
are not excluded.
Yes, sir.
Okay, not and excluded. You know what I mean? So it's included.
Yes.
Okay. It's confused, I know, but it's written like this in the standard, so I have to follow it. Not excluded, okay?
Yes, sir. Thank you.
Yeah. One more example. Yeah, let's do this one and go to the more interesting one. We have a plate 3/8 times 6. Okay, this plate looks like this. Uh, 3/8 means the thickness is 3/8 inch, and the 6 is the other dimension, 6 inch. Is used as a tension member to resist a surface dead load 12 and the surface life load 33. I believe from this information I can set up the value of P ultimate 1.2 dead load plus 1.6 life load. So the value of P ultimate will be 1.2 times 12, 1.6 times 33. This value will be 67.2 kips. This member will be connected to a gusset plate with 3/8 inch. We have here, probably this side will be better, gusset plate. So the two blades will be connected together with 3/4 inch diameter group A bolts. This information is very important. Steel A36 is used by the tension member and the gusset. It determines the number of bolts required. How many bolts here? To connect between this gusset plate and this plate, which is a member, tension member. And this tension member under the effect of P ultimate equals 67.2 kip. Okay, to figure out how many bolts, okay, let's start with what is the design strength of one bolt. This is for one bolt. It's very easy. Very easy. 0.75 N F N V area bolt. 0.75. How many plane of shear? I think we have only single shear, so it will be one. FNV. Unfortunately, we have only given the group A bolts. The problem did not say it's included or excluded. Threaded part is included in the shear plan or not, so you can assume what you want. But we have only one information. This is group A bolt. So you can decide. And please tell me what you decided. Are you decided that the threads are not excluded or the threads are excluded? Okay. Guys, are excluded means not included. Please don't be confused about the meaning of these expressions. Okay. So you can decide. I will decide the first one. 54. Area bolt by divide 4 times 3/4 square. We got this value soon. I think this value will be 17.9. Okay. So guys, how many bolts do you need in this connection? Number of bolts, very easy. Just divide the ultimate or the factored tension force by the design strength of one bolt, I can give you the required number. So 67.2 divide 17.9, the required number will be 3.75 bolt. Do you think number of bolts can be decimal? No. So I need to round this number to the smaller one or the biggest one? Sure, the biggest one, 4 bolts. We need 4 bolts. Even if this number is 3.1, this number must be 4. I cannot go down. I cannot go below 3.1. Cannot. We need 3 bolts and 75.75. We cannot get fracture of bolts. So this number must be integer number to the higher number. So we need 4 bolts. We need to put 4 bolts. I believe I will put my bolts looks like this. If you would like to show me a good sketch, okay, here is the member. This length is 6. I will put the 4 bolts like this. Okay, tell me what is the distance here between the center and the edge? What is the spacing between the center and the center? What is the spacing here? What is the distance to the edge? You have to tell me or answer me all of these questions. Okay, let's do the minimum spacing 3D bolt. 3 times 3/4. This one will be 2.25 inch. So this minimum distance 2.25. You can increase it, it's up to you, but this is the minimum one. So this one must be 2.25. That makes sense? Okay. What is the edge distance between the center line of this bolt and the edge? What is the distance between the center of this bolt and the edge of the member? And what is the distance between the center of this bolt and the edge? We need to use this table. Based on the diameter of the bolt, 3/4, the minimum edge is 1. Okay. So I will use 1, 1, 1. Please check. Please check. 1 plus 2.25 plus 1. Is it smaller than or equal 6? The width of the member? I believe yes. You are good. So this in distance can be increased and this distance can be increased. That makes sense? That makes sense? So probably I will say 6 minus 2.25 divide 2. I will say I will put this distance to be 1.875. 1.875. So if you add this one plus this one plus this one, you can get 6. Okay? Yeah.
If it was actually bigger than 6, you can't decrease it, can you?
Okay, it's a good question. It's a good question. You have 4 bolts. If you are trying to put your 4 like this, and you found the minimum distance between this one and this one is 2.25, and the minimum distance here is 1, and the minimum distance here is 1, and unfortunately, this width is 4. So I cannot reduce this distance smaller than 1. I cannot do it for this one, or I cannot do it for this one. However, the sum is 4.25, is bigger than the actual width of the member. This arrangement is incorrect. You have to change this arrangement. You can put your bolts, looks like this, 1, 2, 3, 4. What's the problem? You know what I mean? So I will put my arrangement looks like 1 row. Does that make sense? if you have issue. So the spacing will be 225, 225, 225. And the minimum edge here will be 1. And this distance will be enough. It will be 2 inch. And you need only 1. So that's good. That makes sense? So please, we are using the minimum spacing and the edge distance requirement to figure out what is the best arrangement of our balls. How many balls? You can get it from this equation. How can I arrange these balls? Please, you need to follow the rules of the minimum spacing and the minimum edge distance. Okay. This part is very important. Please, everybody pay attention to me. Guys, for your truss, probably we have a joint. We have a member here, another member, and another member. Looks like this. This one is tension, this one is tension, this one is tension, this one is compression, for example. That makes sense? For any joint in truss, we have a force, we have a force, we have a force, we have a force. So guys, you decided to use ordinary bolt A307. And you found that the phi Rn equal 8.9 kip. So if you would like to get how many bolts I need for this member, just divide F1 by 8.9. You can get the number. We can assume we need 3 bolts, for example. Okay, for this one, I will divide F2, the force in this member, by the design strength of 1 bolt. I'm going to assume I need 4. For this one, I'm going to assume I need 3. For this one, I'm going to assume I need 5. That makes sense? So please, you have to figure out what is the internal force in each member, which is called P ultimate, which is coming from RISA. And then divide this P ultimate by the design strength of 1 bolt. After you assumed what type of bolt you are using, then I can figure out how many bolts. Can you tell me how can I draw this connection? Okay, please pay attention to me. I will show you something very interesting. Okay, guys, first step, I will draw the center line of each member. That makes sense? Center line of each member. For this member, this member, this member, this member. Next step, you should design this member. So I decided this member will be angle or double angle 6 by 6 by 1/2. So this width is 6 inch. The other one, I decided this member will be double angle 8 by 8 by 1/2. So this width will be 8. Make sure I did it wrongly. I'm sorry. Make sure the difference between 6 and 8 from the top, not from the bottom. So this one will be at the same height, like this. Also, you can extend this one to be further, like this. Then, The vertical member, I decided to be one angle four by 1/2, for example. So this width will be 4. The inclined angle, I decided to make it 3 by 3 by 1/2, for example. So here is the angle. This width is 4. Please make sure that the center line is passing through this distance is 2 and this distance is 2. Any questions so far? So the first step to draw this connection, please draw the center line. Then go ahead and draw your members without any intersection. You decided that this member need 3 bolts. So I will put 3 bolts. 1, 2, 3. And make sure what is the edge distance, what is the spacing between each 2 bolts. This member will need 4. 1, 2, 3, 4. This member will need 3. 1, 2, 3. This number will be need 5. 1, 2, 3, 4, 5. Any questions so far? After the last bolt, please measure another distance, which is edge distance also. Edge distance, edge distance, edge distance. Finally, go ahead and connect between this one and this one. This is the shape of the gusset plate. That will be used for this connection. Can you watch? We have a member. We have a member. We have a member. This member will be connected by this gusset plate. Can you watch it? This one. This member and this member and this member and this member. This one will be connected by this gusset plate with this shape. How can I construct this gusset plate? One more time. I will explain it one more time. Guys, for example, we have a connection like this. Here is the column, and we have member, and we have member, like this. For the truss, this one is tension, F1. This one is compression, F2. Based on your design, I need here 4 bolts. I need here 3 bolts. So regardless the column, I don't care about the column. Here is the column. I don't care about it. Okay, let's do it first. Center line. The column, center line. The horizontal member, center line. The inclined member, center line. For columns, and I will cover it probably after the exam one, will be W shape. Like this. W shape means your shape looks like this. This is the plan. If you are looking elevation, you will see this line and this line, this line and this line. So it looks like this. So if you are looking from this side, I will see these two lines and these two lines. That's it. Anyway, the horizontal member, I decided that the horizontal one will be double angle, two angle, 8 by 8 by 1/2. So this distance is 8 inch. The inclined member is one angle, 4 by 4 by 1/2. So I will draw it 4 by 4. The horizontal member needs 4 bolts. 1, 2, 3, 4. Please do, what is the edge distance? What is the spacing? Center line, center line. By the last one, I will measure the same edge distance to be here also. Here I need 3 bolts. 1, 2, 3. Then you can connect between this one and this one like this to figure out the shape of the gusset plate. Does that make sense? Here is the connection, the real life connection between this member and the column. So guys, first step for truss connections, you have to draw the center line. Center line for each member, center line for each member, center line for each member, center line for each member. And all of these center lines connected here, which is the joint of the truss. Second step, you need to draw the horizontal member first from this side and this side, then the vertical member, then the inclined member. Once you are done, go ahead and put your bolts based on how many you want, and then the edge of the gusset plate like this, vertical. It's not a vertical line, it's a line perpendicular to the member itself. Then if you connect between this one and this one, this one and this one, this one and this one, you can figure out the shape of the required gusset plate, because you need to construct this gusset plate to be ready to make holes, and on site you can connect these members by the gusset plate to construct the truss. Any question? Is it interesting? Yes, yes, Oliver. The same edge distance. The same edge distance. The same. This edge distance will be the same here. Okay. Any question, guys? So right now, we can design tension member and compression member, and we can figure out how many bolts we need, and we can figure out how we can arrange these bolts. Next meeting, next week, I will go through welding. If you have welded connection, what will happen?